Welcome to System Design Interviews. Episode 1. This is a mock interview, start to finish. I ask, you answer, and the whiteboard only fills up when the answer earns it. Today's question: design a URL shortener.
Here is your prompt. Design a URL shortener, something like bit.ly. A user gives us a long link, we give back a short one, and the short one sends people to the long one. Take as long as you need. Where do you want to start?
Before I draw a single box, I want to ask you 4 questions. Most candidates start drawing here. That is the mistake. I do not know how big this is, and I do not know what it has to do. If I guess those wrong, every box I draw after that is wrong too. So the board stays empty for 2 more minutes.
First question. How many new links do we create per day? And for each link, how many clicks does it get?
10 million new links a day, and reads are about 100 times writes.
Thank you. Second question. Do custom aliases have to work? By that I mean, can a user ask for a specific shortcode, like /summer sale, instead of taking whatever we generate?
Yes, paying customers can pick their own alias.
Third question. Do links live forever or do they expire?
They expire. 2 years by default. The user can set a shorter time.
Last question. Do we need click analytics, or do we only need the redirect to work?
We need click counts, per link, per day.
Good. Let me read that back so we agree. 10 million writes a day. Reads are 100 times writes. Custom aliases must work. Links expire after 2 years. And we count clicks per link per day. That is my contract for the rest of this hour. If any of those 5 lines changes, the design changes with it.
That is the right start. And let me tell you what I am actually testing here, because it is not what people think. I am not testing your hash function. Any hash will do. I want you to choose where this data lives, and then defend that choice when I push on it.
Then let me put numbers on it first, because the numbers pick the store. 10 million writes a day, divided by 86,400 seconds, is about 116 writes per second. That is nothing. A single machine does that. Reads are 100 times that, so about 11,600 reads per second. That is a real number, and it is the number the whole design has to survive.
And how much data is that after 2 years?
10 million a day times 365 days times 2 years is 7.3 billion rows. Each row is a shortcode, a long URL, an owner, and a date. Call it 500 bytes. 7.3 billion times 500 bytes is about 3.7 terabytes. That fits on one disk today. So this is not a big data problem. It is a high read rate problem.
One more number, and this one decides the shortcode. I need at least 7.3 billion different codes. Base 62 uses the digits, the lowercase letters, and the uppercase letters. That is 62 characters. 6 characters gives me 56 billion codes. 7 characters gives me 3.5 trillion. I will take 7 characters and never think about it again.
Now I will draw. First box, the client. Second box, one service. It does 2 things and nothing else. It takes a long URL and gives back a short one. And it takes a short code and sends the browser to the long URL. Notice, this is not a microservice diagram. At 116 writes per second, one service is honest. Third box, the store. And here is the whole data model. One key, the 7-character code. One value, the long URL, plus the owner and the expiry date. That is it. There is no second table. There is no join. A URL shortener is a hash map that survives a restart.
Stop there. You wrote key value store on the board. Why not Postgres?
We already run Postgres.
Fair push. Look at the read path. Every read is, I have one exact key, give me one exact value. No ranges, no sorting, no joins. Postgres can do that, and at 11,600 reads per second, it would probably cope. But I would be paying for a query planner I never use, and I would have to shard it myself when the table hits 7 billion rows. A key value store shards by that key for free, and the key is already the thing I look up. So, Postgres if this is a side feature of an app we already run. A key value store if the redirect is the product. Here, the redirect is the product. Now, how do I make the code? Take the long URL, hash it. Any hash will do. MD5 is fine. That gives me a big number. I take the first 41 bits of it. 41 bits is a number under 2.2 trillion, and base 62 writes any number that size in exactly 7 characters. So I encode it, and out comes the code you can see on the board. That string is the key I store, and it is the key the browser sends back to me.
What happens when 2 different URLs give you the same 7 characters?
They will. 7.3 billion codes into 3.5 trillion slots is rare, but rare times 10 million a day is a real event. 2 ways out. 1, try to write the code, and if the key already exists, take the next 41 bits of the same hash and try again. 2, skip the problem. Give every service instance a block of numbers, count up, and base 62 the counter. A counter can never collide with itself, but a counter is guessable. I can visit code 1, code 2, code 3, and read every link anyone ever made. So, retry on collision for public links, and a counter only if you are happy for the codes to be walkable. I will take retry.
Good. Now at 11,600 reads a second, what breaks first?
The store. And not because of the total load, because of one link. One link goes viral, and that is one key, and one key lives on one partition, on one machine. The average is 11,600 a second, spread over billions of keys. The peak is 50,000 a second on a single key. So I put a cache in front of the store. The codes never change once they are written, which makes them perfect to cache.
And what does that cache cost you?
3 things, and I will say all 3. 1, a cached redirect is a stale redirect. If a user repoints a link or deletes it, the old target keeps working until the entry expires. So I keep the cache time short, about 5 minutes, and I delete the entry on an edit. 2, the cache is now the thing that must not fall over. If it goes cold, the store takes the full 11,600 at once. 3, and this is the one people miss, the click count. If the cache answers the request, the store never sees the click.
So I do not count clicks in the database at all. Every redirect writes one small event to a stream, the code and the time. Something else reads that stream and adds up the counts per link per day. The redirect never waits for the counter. If the counter is 30 seconds behind, nobody notices. If the redirect is 30 milliseconds slower, everybody notices.
Last question, and then we are done. Your redirect. Do you send a 301 or a 302?
This is the one that catches people. 301 means moved permanently. The browser is allowed to remember it, and it does. So the second time that user clicks the link, the request never reaches my server. My click count flatlines, and I can never repoint that link because the browser is not asking me anymore. 302 means found or temporary. The browser comes back every single time. That costs me 1 request per click, but that request is the product. That request is the click count, and it is the only reason I can change where a link points. So, 302, and I would say that out loud before you asked.
That is the answer I was looking for. Not the hash, the store, defended, and the redirect. Understood. That is episode 1. If this was useful, hit like and subscribe for the rest of the series. The written version of this question, with the 4 clarifying questions and the trap, is on the blog.